Okay, this is just to finish up our notes on some details in the regression, the least squares regression line. I wanted to go back and make sure that you had clear notes on how to plot the residual. So once you put your data into L1 and L2, remember that you have to go get your equation first. So you're going to go stat, calc, go down to number 8 and get your equation. Then, if you'll go back to stat, to calc, get up on your L3. So you need to tell your calculator to find the residuals. So once you get up on your L3, which is right here, then you're going to go to list, which is second stat. You're going to go to names, which I think is the first one that pops up, and this one right here should be here, number 8, which would be residual. Hit enter again, and all the residuals should pop up in your L3. If you wanted to, you can do a one variable stats on your L3 and make sure that the sum of the x's is really, really close to 0. You can also check that your x bar should be really close to 0. Don't have to do that, but that will always be the case. To graph your residual plot, you're going to turn your stat plot on, and then you're going to go make sure that you're L1 and L3, and then make sure you do zoom stat. So if you'll do those things and you have this video so you can write this stuff down or do it enough to make sure that you're comfortable with it, and you'll practice it in the homework, but that's what's going to give you your residual plot. And then just make sure that you can interpret the residual. And then just remember that the residual is y minus y hat, which is observed minus predicted. So if your residual is positive or negative, just make sure you're paying attention to who that means is bigger. Did you overpay or underpay? That kind of stuff for your conclusion. Okay, I want to briefly go back and talk about the standard deviation because I feel like we were running out of time and kind of went through that really fast. You do not need to be able to use that formula. It is on your formula sheet, but you will always be able to find your standard deviation under your one variable stat. Okay, once you find your standard deviation, we interpret this value as the typical, and there's one of the, that's just one of those favorite words, distance of the data points from the mean. So if we talk about the residual for the standard deviation results, if you have all your data in your L1 and L2 and you do all your stuff and then you go stats, calc, one variable stat, and then you go down and find your S sub x, you're going to see that it's 5,740. So here's your sentence. You have to start with the fact that you're using a least squares regression line and what information is going into your least squares regression line. So it says, when we use the least squares regression line to predict the price based on mileage, and that first part is so important. Then the last part is easy. Our predictions will typically be off by $5,740. Remember, standard deviation is how much your data fluctuates. So we're saying typically we're going to be off by $5,740. But again, loading that front part of that sentence is so important. The more you do these, the more you practice. So really focus on your sentences there in your homework. Okay, the coefficient of determination is your R squared. It is literally your coefficient, your correlation coefficient squared. We interpret it to mean that R squared percent of the variation in Y is accounted for or explained by X. Okay, the coefficient of determination is given on your calculator directly above the correlation coefficient. You get your A and your B and your R squared and your R. So we're looking for R squared. So let's talk about it for the Ford F-150 data. So this is not found under one variable stats. This is stat, calc, and then down to number 8 where you get your linear regression line. And then it gives you Y equals, and then it gives you A and B and R squared and R. So that's where we're looking for the R, R squared. Okay, so here's how you interpret your R squared. And again, you've got to talk about the linear model, and you've got to talk about what information is going into the linear model, okay? So it's 66.4%, because that's what my R squared is. 66.4% of the variation in price. Because remember, it's not that everybody who has this amount of miles on it will sell for this price. There was variation there. So of the variation in the price is accounted for or explained by the linear model that relates the number of miles driven to the price. 66.4 of the variation in price, because that's the thing that varies. The miles don't vary. We use the miles to predict the price, but it's not always dead on. In fact, it's very rarely is it dead on. So we're talking about the fluctuation in our results. I've got a truck that has 100,000 miles on it, and so do you. We're not going to sell it for the same price because there are other confounding factors that will cause my truck to be worth more than yours, or your truck to be worth more than mine. So 66.4% of the variation in our prices is accounted for the linear model, our equation, relating the number of miles driven to the price. And again, the more you practice that sentence, the better off you'll be. Okay, in section 3.1, we looked at the relationship between the average number of points scored per game and the number of wins for 12 college football teams in the SEC. We're going to use the given information to answer the questions below. So we'd already gotten our equation. There's my R squared, and I found my S. I've got my graph, and I've got my residual plot. Make sure you understand where all this stuff came from, and make sure you would know how to go get it, where everything is. It says calculate and interpret the residual for South Carolina, which scored 30.1 points per game and had 11 wins. So 30.1 points per game and had 11 wins. South Carolina won 1.6 more games than expected based on the number of points scored per game. So if I find 30.1, that's this guy right here. So the residual is going to be the difference here. I'm not going to eyeball that. I know that they had 11 wins. Guys, that is my observed. I know they had 11 wins. Now, how do I get their predicted? Well, I'm going to take 30.1 and I'm going to plug it in for my X, and I'm going to get the predicted. And I got, let's see, I think it's 9.4. So the residual is a 1.6. And not only is it a 1.6, it's a positive 1.6. So then you would start to tell me what that means. And I don't need you to say anything about South Carolina played better. I don't need any like football analogies. I just need, what does this mean? Well, it means that they did better than they were predicted to do. So South Carolina won 1.6 more games than expected, but this is the important part. Based on the number of points scored per game, because this is what they were predicted to do based on the points. Now, there could be other confounding factors. The team they played could have lost their star quarterback, or a star defensive player could have been injured, whatever. There are other confounding factors. So that's why that based on the number of points scored per game is so important. Is a linear model appropriate? Look at your residual plot. Absolutely. There is no pattern in the residual plot, so yes, a linear model is appropriate. Interpret the value of S. That's your standard deviation. That's the 1.24. These last two have stars by them because these are the sentences most kids screw up on. But guys, if you will just remember the pattern of these two sentences, it is super easy. But don't try to BS your way through this. Interpret the value of the standard deviation. When using the least squares regression line to predict the number of wins based on the points scored per game. Guys, all that is front loading where my information is coming from. I'm using the least squares regression line. What am I doing? I'm predicting the number of wins based on what? Based on the points scored per game. Okay, once you say that, then you're going to say we're going to typically be off, like our answers, our output is typically going to be off by 1.24 wins. Interpret the value of R squared. Came out to be 88%. About 88% of the variation in wins, your output, the variation in your output, your Y's, is accounted for or explained by, and then again, the linear model relating the number of wins to the points per game. Then you can do this furthermore sentence. 12% is explained by other factors like injuries, academic probation some of the students may be on. Maybe it was raining that day. But they're 12% of the variation explained by other factors. Okay, sometimes they're going to give you this, it's called a Minitab, and it's just giving you the same information, but I just want you to know where all the information is in a Minitab, and I think you've got a couple in your homework. But it's a great way to give you a snapshot of information quickly. Okay, and obviously it's not going to be highlighted. I did that just to show you. Okay, I want you to, it's always going to have the word constant. Right beside the word constant is your y-intercept, which makes sense because the y-intercept is a constant. Then it's going to talk about what it's measuring, the miles driven. That is going to be your slope. So 0.16252 over 1. Okay, then this S, that's your standard deviation. R squared, that's your R squared. You don't need to worry about what anything else is. We'll get to all of this stuff, but just not in this chapter. If you know R squared, just remember that you can find R, which we'll do here in a second. Okay, so let's look at this guy. So here's a little mini tab. This is a random sample of 15 high school students was selected from the U.S. Census at School database. The foot length in centimeters and height in centimeters of each student in the sample were recorded. Okay, so here I go. Constant. Beside the constant is the y-intercept. Beside the foot length is going to be the slope. S, that's my standard deviation. And there's my R squared. Okay, again, in the exact same place it was before. And it will always look like that. Then they were super nice and gave me my scatter plot with my line and my residual plot. Very nice of them. What is the equation of the least squares regression line that describes the relationship between foot length and height? Define any variable that you use. I'm not always going to say that. You have got to remember that. Okay, so if it wants the equation, well, guys, I don't have any data to type into my L1 and my L2. But remember, they gave you the y-intercept, and they gave you the slope. So my 103.41 that's highlighted yellow, there's my 103.41. There's my y-intercept. And then if I look at my slope that's highlighted in green, 2.7469, there's my 2.7469. And he gets the X because he's the slope. Don't forget your Y has to have a hat on it. And don't forget to define your variables. Y hat, have to have this word, predicted height in centimeters, and X is your foot length in centimeters. Thesis, interpret the slope of the regression line in context. This is my slope. Put it over 1. And it's for each additional centimeter in foot length, we predict an increase of that many centimeters in height. This is the word that's important. C, find the correlation. Okay, not the coefficient of determination, but the correlation coefficient. Okay, well, it told me that my R squared was 48.6%. So if my R squared is 48.6%, so 0.486, then R is the square root of that. Now technically, remember, your R can go from -1 to 1. So your R could be positive or negative. So when you square root this, I'm leaving the plus or minus on there because I don't know if it's positive or negative. But I know that my slope is positive, so I know this line is going up, so I know my R has to be the positive version of that number. If my slope was negative, I would have to know that my R has to also be negative because there's a negative relationship. So 0.697, as far as correlation coefficients go, this guy's pretty not exciting. A 0.697 is not anything to get super excited about. Is a line an appropriate model for use for this data? Explain how you know. Yes, it is, because the residual plot has no patterns. So I hope this has helped kind of clean up some stuff we did in class, and then also kind of put it all together. So you guys see how I can give you one situation and ask you multiple questions about, and that's what your quiz is going to be like. Really focus on your homework. Make sure you know how to do all the things you need to do on your calculator, and make sure you know how to write those sentences, especially for your coefficient of determination, your R squared, and especially for your standard deviation, your S. Okay, and if you have any questions, come see me.